Okay, so here you have one example of the resolution in R of one of the least square adjustment exercises following the four steps. So in the first step, I hope everything it's already familiar for us, but we are going to learn a few concepts also for R. Anyway, you should go through, you should learn, and I'm just giving you the keys, okay, here to solve this exercise. So first step is the identification step. Yeah, basically we build our matrix of the observations, the matrix S, and the corresponding times. Remember the exercise, yeah, the exercise 1 of least square adjustment, or exercise 2. You will see the data, okay. I can see there is a mistake here with the data entries, because this data should actually correspond to this data. Yeah. So let me just open the other exercise just to make sure we are entering the right data. Okay. Downloads. Exercise. Should be this one. Yes, so it's 135. Yeah, there's a mistake here, but T. Okay, so yes, let's enter the same data as in this exercise. So we have for S is 363. To 1116. And then for the time, we have 135, 13578. 13578, 10, 12, 15. Okay, so how many rows are we defining here? It's actually also one row. Yeah, we are working with a okay, we need to be careful here because this is basically the dimension of the vectors. Remember when we were explaining how the matrix should be structured, we decided to work with column vectors. Yeah, so that means uh, one column, many rows. So this is basically something we can also define here by the number of rows. How many rows do you think we need here? As many as data they are inside to get our column vector as we did in the exercise, in the theory. So it's 1, 2, 3, 4, 5, 6, 7, 8, 8, and the same here. Yeah. Okay. Um, okay, we'll see this actually later while we are defining these things, because we need to make sure we are fitting all the dimensions properly. Now I'm just going to explain the basics and then we'll see the application. But in any case, the first step is the identification step where we store, we create our vectors. Yeah, we'll pay attention to the dimensions later. Then we have our functional model. How are we defining the functional model? Basically, we will define each of the columns. Yeah, each of the columns according to the A matrix, and then we will merge each column, and this is the way we have to do this. C-bind means concatenate columns. So the first column is 1, 1, 1, 1, 1, 1, 1. Remember in the exercise, the second column is T, okay? So this vector, the third column will be T squared, so that means we are squaring each of the elements, and the third column is sorry, I entered something. The third column is the cubic, of T, and then the A matrix, to bind all the A matrix, we just concatenate them. Yeah, you make a concatenation to have all together, and then this is basically the adjustment step. Solve is invert, is the inversion, and we have transpose is T of A. T is the function, A is the matrix. This is the way the symbol we use to make matrix multiplication. And again, transpose of A and transpose of S. That's what I meant at the beginning. Sometimes you can just define the vector as a column vector, and then if you see afterwards you need to transpose, you apply the transpose. Yeah, just to convert a column vector into a row vector. And that's all. Basically, here is just the application steps where we are giving values to T. Yeah, to T, just to generate a grid of values. Okay, so this is an example. Again, identification step where we create the input, we define the vector of the observations, and also we set the basics to generate the vector of the coefficients. The functional model where we enter according to a specific structure of the A matrix, according to the model we are working with, the values of T, and then the application step, which is the least square formula, and then the application step. Tricks here is basically functions we are using is the concatenation, the bind, and the transposing, multiplication, and inverting, which is this solve. So let me just show line by line what we are doing now in R. So let me open the R code, the R software, R Studio, and we'll show you how it works.